let's go. So let me know if you can see my screen now. Can you see my screen now?
Yes.
Ah, okay, yeah, good one. Okay, so let's start from the very basics. So, um, at the very basics, like you go for a job interview, they're asking you, so what is the EIGRP? Well, what's it used for? What's the purpose of the EIGRP? What would you say? What would be your answer?
The routing protocol.
Mhm. Yeah, good one. Very good one. A routing protocol. And so, because this group is a group where we explain things to one another, what do you mean by a routing protocol? What do you mean by a protocol? What do you mean by when you say it's a routing protocol?
It
It's a normal thing that we know in Cisco world, but maybe for maybe people that may not understand, what do you mean by routing protocol? Yeah,
it's it finds the best route to the nearest neighbor or to a host.
finds the best route to the nearest neighbor or host. Okay. Okay. Anything else, or does anyone want to add anything else? At the very basics, what is the IGRP?
It's a distance vector protocol.
Okay, so let's put that down. Distance vector protocol. Anything else? Okay, you say distance vector protocol. What do you mean by distance vector protocol?
Um, okay, I think it chooses the best path uh, in terms of distance, and then it just calculates which is the best path to reach a destination.
And then calculate the best path to reach destination. So anything else that you want to add that anyone else wants to add?
It's Cisco proprietary.
Okay.
No, not anymore.
Yeah.
So use
I think
okay.
3 years back.
Used
Used
to
to be,
be
yeah.
Cisco proprietary.
Well,
But
the thing.
does anyone know any other devices out there that has implemented EIGRP? Does
Yeah,
anyone
it's
know?
open. You mean to say any other vendor?
Yeah, any other vendor, like maybe Brocade or HP or any one
Yeah,
of
I
them.
think so. Yes, they can because it's open now. It's no
Yeah.
longer, it does not, yeah, it's no longer Cisco proprietary. So yes, it can be open standard.
Hmm. Okay. Okay, yeah. So yeah, apart from this, what other information, just general information about what EIGRP is and the way it works?
EIGRP,
EIGRP supports unequal cost load balancing.
Ah, okay,
yes.
good one. So now you're making it much more complicated now. So you have to explain to us. So what do you mean by unequal cost load balancing?
Yeah. Generally, regarding like if you see other protocols like OSPF or anything else,
Mm,
if we have two links between a source and a destination, it will choose the link with the maximum bandwidth. But in case of EIGRP, if you have two links between a source and a destination,
mm,
it will have let's say the first link is of a higher bandwidth of 10 gigabits and the other one is of a lesser bandwidth like mbps.
mm.
It would be load sharing would be possible between, it will share the load in the ratio of say 10 is to 1. In that ratio it can share the load and the traffic would be shared.
Ah,
And
okay. You probably show, yeah, I think as we go on, you probably show us how to do that also. So we'll be really clear. Okay, so let's move a step back because at the very basics of EIGRP, for in case we've got like any new people at the very basics, like what we said, it's a routing protocol. What's a routing protocol? You have a router on your network. The purpose of a router, in our previous discussion, is to get you from one network. I mean, at the very basic, is to get you from one network to another network. If you're operating within a single network, all you need, at the very basics again, you're just talking about basics now, all you need is a switch. if you're going to be talking between devices on a single network. But then if you now want to go out of that network and talk to another network, so let's say we've got network one here. We've got network one here, and network one, all the devices on network one are connected to a switch. And we've got network two here, and all the devices on network two are connected to a switch. Now, to communicate between network one and network two, you can't just communicate directly like that. You need something that will carry the packet from one network to another. That's the router. So we discussed in our previous discussion that the very basics, for the way the router works, it works using something which Sarah explained beautifully to us the last time. Router operates using something called a routing table. And basically, a packet comes to the router looks at it and says, which network are you going to? Depending on which network you're going to, it looks in its routing table at the time and determines this is where I'll be sending you to. If a packet comes to this router and it looks in its routing table and there is no match in the routing table, what will the router do with the packet?
It will drop
It
Yeah,
will
the
good.
packet.
broadcast it.
Yeah, good. So you basically just drop the packet because I've got no place to send you to. I'll drop this packet. So at the very basics, that's the way the routing table. And then the last time we discussed the content of the routing table. Like what would you find in the routing table? Does anyone else still remember what are the things that we'll find in the routing table? Because all this tie in when we go a lot more into EIGRP. So what are the content of the routing table? Content of the routing table. Just a little bit of revision from the last time we discussed. What will I find in the routing table? Petros, you want to try?
Okay. I would say the destination address.
Good one. Excellent. The destination address. Excellent. What else are we going to find? So that's a really, really good one. Destination address. What else? Because like we said last time, as network admins, we must be able to look at the routing table and determine, looking at the routing table, we should be able to tell anything going to this place is where they're going to. But then we must understand exactly what the routing table is telling us. So what content? So destination address, anything else?
Uh, okay.
Mark, you want to try?
Okay.
So what else?
Yeah, there's routing protocol. I mean, it shows you the routes. It shows you connected routes. It shows you whether it shows you connected routes, static routes.
Yeah. So it shows
It
you
shows
all
you
the routes. Yeah. So basically the routes are the destination
interfaces.
addresses or the destination. Hey, okay, sorry, Petros. There's a
Yes.
little bit of a mistake here. Which mistake is there? You said destination address.
I'm not sure.
Does anyone want to assist with that? So what's wrong with saying destination address?
I suppose it should be destination IP address.
IP.
Destination
Yeah.
IP address. That's
IP.
even a bit backward now. That's a bit worse now. Destination IP address. Does anyone think that the routing table deals in destination IP addresses? What do you think, Mark?
I think that's accurate.
That's accurate. Okay, Power says okay. Yeah, yeah. Okay, I mean, so something is wrong with this one because routers don't look at it. So, Sarah, what's wrong with this one? So, what you find in the routing table, destination IP address, is that what you find?
And the interface it goes out with.
Yeah, but even before you get to the interface, so what's wrong with the
Okay.
statement of saying destination IP address?
Oh, okay.
Sarah, you want to chime in? I mean, I know it's like, terminology. I know you know what you're talking about.
The outgoing port.
Yeah, no problem. Okay, yeah. So power go I was talking about, yeah. So I was talking about network, destination network. Because routers typically deal in networks, not necessarily, host addresses or IP address. They normally deal in networks, right?
Yes.
Yeah,
Okay.
Okay.
yeah.
Yeah.
So destination
Destination
network.
network,
Yeah.
yeah.
But then there's a situation of where Powell said that you can route, to a host using /32. Yeah. And
Mm.
stuff like that. Okay, yeah. Destination network. So you have the routing protocol that Mark mentioned. What else? Destination network, routing protocol. We mentioned this the last time. We mentioned something else.
Uh,
Outgoing port.
Outgoing port. Good one. Excellent. Outgoing port or what? Oh yeah,
and the
let's say outgoing
and the
port.
cost.
Good one. That was,
Yeah.
that's like one important one to note. He
Yeah.
he put something called cost.
The
Metric.
met
Yeah,
the
net.
metric and the cost. Yeah.
Yeah. So you find that in your routing table also. So at the very basics, that's how it works. Now there are two ways that this routing table can be populated. You can either go in as a network admin and populate it manually yourself, or what you can do is run certain protocols on each device. So let's say you have a router here, you have another router here. What you can do is turn on a routing protocol on this router, yeah, and turn on a routing protocol on this router also, and then the routing protocol on this router and the routing protocol on this other router, provided that all conditions are met, they will talk to one another and share routes to one another. So what will happen in this case is this routing protocol will talk to this routing protocol on this other router and say to it, well, I know about this network called network 2. And this one will say, oh, you know about network 2. And this one will say, I also know about a network called network 1. So that way, this router will know if I want to send anything to network 1, I can send it to my partner here. And if I want to send anything, to network 2, this other guy knows I can send it to my partner here, and he knows how to get it to network 2. So let's move a bit further. So breaking all this down in EIGRP terms, can someone, just someone, take us through how EIGRP works? So in this particular scenario, take us through from the very beginning how, if I go on this router and I turn on EIGRP here, yeah, it's the kind of thing that I expect that, to be asked if I go for an interview, in a firm that uses Cisco, where you say, okay, explain to us how EIGRP works. You've got EIGRP running on this router here. You've got EIGRP running on this router here. This router is connected to network 1. This other router is connected to network 2. So explain to us exactly how EIGRP will go about populating the routing table in this case. So who wants to go for that? So wants to go for that? Explain how EIGRP works to us in your own, I mean, the way you see it. You don't have to be right, You don't have to be right. Just explain to us the way you understand it, how EIGRP works. Asad, you want to go first?
Uh, yeah,
Yeah,
I'll go.
thank you.
The first thing,
Mhm.
uh, it will look up to the destination IP, and it will make an entry in the routing table.
So, I mean, let's start from the very beginning. I go on this router and I turn on EIGRP on this router. And then I go on this router and I turn on EIGRP on this router. What exactly will happen?
Okay, one thing that I will say
Yeah.
with EIGRP, I like to think of it as limited visibility.
Okay.
Okay,
So
it on
let's put that down. EIGRP is limited visibility. Okay.
right.
Yeah.
So
Carry on. Yeah.
if you are preparing for CCNA, it is very important that you understand what is the difference between a distance vector protocol and a link state protocol.
Yeah.
Link state would be your OSPF or ISIS.
Mhm.
So what happens with EIGRP? It's also called routing by rumor because it only knows what its neighbor tells it. Okay, R1 will only know what R2 will say to it. On the other hand, a link state protocol like OSPF, it has much deeper understanding of the entire network, as in it can see the whole network.
Yeah.
But EIGRP can only knows what the neighbors about its neighbors. It does not know beyond the neighbor it is directly connected to. So the topology that
So
David had just now.
yeah, Sarah is dropping a lot of good knowledge. That's why I'm I'm quickly so I can bring the point and make it clear. So yeah,
You want me to say it again?
I said you're dropping a lot of good knowledge that I had to move to another widescreen, another whiteboard.
No?
Okay, yeah, carry on.
Yeah, the keyword is limited visibility because it only knows what its neighbors is going to tell. On the other hand, OSPF is like a map. OSPF uses this what's that algorithm called? I'm going to embarrass
Dice
myself.
SPF.
Dijkstra or
Yep.
something.
Yes.
Yep.
So this algorithm, I believe it's also used for GPS.
Mhm.
Yes.
Dijkstra
Right.
algorithm.
Navigation, yeah.
It is used, right? Because it has a whole entire knowledge about the entire the world or whichever country you stay in. But no, not EIGRP, which uses dual, that is diffusing update algorithm.
Yep.
Yeah, so this is the difference. This is the main difference that you have to know for CCNA because you have both EIGRP and OSPF covered there.
Okay, Sarah, just on EIGRP, the dual diffusing algorithm, how does it actually differ from the Dijkstra algorithm?
Though there's a huge, big, massive difference because what is dual used for? The plus point of EIGRP is it converges faster, right? I mean,
Yes, it
to the
converges
best of
faster, yeah?
to the best of my knowledge so far, yes. But I mean, of course, I have read a lot of people arguing over that because they get
Yeah,
into the details of
yeah.
OSPF.
I'll also go. Yeah, I also go in terms of like I really don't think that there is really like a huge difference between like but then yeah. I mean,
But
it's
I think it's very because I'm still getting into details of OSPF, so I'm not qualified enough to comment on that. But the reason EIGRP converges faster is because it has this concept of backup route,
yeah.
right? A backup path. You have a network A which wants to reach destination D. You have a path in your routing table which shows you how to reach there. So happens
Okay.
that path fails. What happens
Yes.
then? You immediately, without doing any computations or anything, you immediately, within like sub-second, you switch over to the backup route, which is technically it's called as a feasible successor in
Yes.
EIGRP terms,
Okay.
right? This is a backup route. So yeah, it's there. You just switch over, and that's it. The network gets converged, and everything is stable. A passive state. That's called a passive state. In case of because you were asking the difference, right?
So yeah, I mean the main thing that we had, which I mean, there's a lot of stuff that Sarah has mentioned, but yeah, carry on, man. I'm really, yeah, I'm really learning a lot of stuff from what you're discussing. So carry on, please.
Okay.
Yeah.
Right. So what happens if the backup fails, the backup route? There are many reasons. Probably there does not exist, or the backup route itself has failed. That is when dual runs. I was reading about this a few days back, actually. I did not get into the details. Dual is not technically the algorithm. It runs on something called FSM, which is a finite state machine, right? It runs on that, and apparently that is the algorithm, but that's where my knowledge ends. So what happens if there is no backup route? That's when dual starts running, and it will start computing it will start looking actually, and to be even more technical, it will start querying for a backup route. So
Okay.
Wait,
it's like
OSPF or EIGRP?
Ask the
yeah,
question again, Mark. What's the question
Okay.
again?
No, I was saying, is she on OSPF now or EIGRP?
No,
EIGRP.
yeah, Choppy.
Okay.
The backup route is only a concept with EIGRP, not OSPF.
Yeah, because I just wanted to, yes, I just wanted to know the dual algorithm part because I just wanted, I know about it, but I didn't know what's its core function.
Yeah,
It
no, I'm coming
is.
to the difference. You will understand
Okay.
it even better.
Okay.
So yeah, you lose the backup route. You are going to be running dual again. Now that takes a bit because you're going to be sending queries. Like for example, I lose the route, I will send a query to you because you're my neighbor. I will ask you that I have lost my main route, my main path to this destination. Do you have a different way to that destination? If you have, you will give me the reply saying, okay, here it is. You don't have it, you will send it to David. David doesn't have it, you will send it to Mark. It goes on till somebody has a backup route and they reply. This is the whole process of dual. It's query, update, reply. A lot of packets are sent. Now comparing this to OSPF, the difference is OSPF does not have a backup route. Okay? If it loses a route, OSPF runs an SPF algorithm, the shortest path first algorithm. So I'm running OSPF, I lose my route. I am going to calculate everything all over again to look for a different route. You are going to do it. Each router in my area is going to compute again.
But remember,
it does have the backup router though. I mean, you have the active router, and then you have they have the designated router, and then you have the backup designated router if it's on network, unless it's a point-to-point.
No, that's a complete different. The whole concept. Designated router, backup designated router is like, think of a person, like I don't have to send everything to you or to somebody else. I have this main person who is designated, who is going to distribute the database.
But here's the thing. Remember also that OSPF has another table.
So if there's OSPF also notify the designated router. The designated router tells you what. Like if there's another route, like the designated router knows all the routes.
Not necessarily. No, because here's the thing that OSPF also uses the routing table. But remember that OSPF also has like EIGRP. It also uses 3 tables. So
OSPF does not have a backup route at all.
Yeah,
OSPF
it doesn't. But then remember that like the speed. So you're talking about like the speed of computing using SPF.
Where it makes a difference is if OSPF loses a route, it will recalculate. In case of EIGRP, if there is a backup route, it does not have to recalculate. It immediately switches. So that bit where you're immediately switching to the backup route is where it wins over because there is no recomputation. So it does not take time anymore as compared to OSPF.
Yeah. Very, very good, Sarah. Excellent. And any question regarding the things that Sarah just explained? I mean, let's go back a bit and let's go a bit slowly. Let's go back a bit. So Sarah has mentioned like a lot of like really wonderful things, but let's try to go through them slowly. So says number one thing she mentioned said AIGRP is routing by rumor. It only knows what its neighbor tells it. So let's start from the very beginning. So how does EIGRP find its neighbor? So that was like the first question of I switch on EIGRP on this router, I switch on EIGRP on this router. How all of a sudden does this router know about this router? What exactly is going on between them that they will know about each other? How do they learn about the neighbors? So that's like the first thing that we should probably go with. So we have EIGRP switched on here. You have EIGRP switched on one router. They are connected using a cable. What will happen?
Okay, they need to be on the same autonomous number, if I'm correct.
Yeah, but how, where does all those come in? The automatic, they need to, you're right. Good one. So the first thing is that they will send something called hellos, to one another, right? So that's the way. So EIGRP, neighbor discovery,
yes.
Then adjacency.
The first thing it does is when you configure EIGRP on an interface. You do router EIGRP 1, and then you give the network statement. What does the network statement do? Whatever addresses are specified in the network statement, it is going to enable the EIGRP process on that interface. Okay?
Yes.
So then there is this whole protocol thing called the hello protocol, which David mentioned. So this is, they will start sending hellos to each other to discover each other. What does the hello packet have? Asad, I think what did Asad say that just now?
Yeah.
The ASN? Yeah. Okay, so it has the ASN. In case of EIGRP, the ASN number
So
has to
again,
be,
so Sarah, let's go back a bit. So now, it said AIGRP neighbor discovery. When you configure AIGRP on an interface, they will start sending hellos to each other. So
hello.
what exactly is inside that hello messages that they're sending to one another? Because that will lead us to the next part of, whether they're
Uh,
going to form a relationship.
It's like I'm trying to tell you that
Yeah.
I'm running EIGRP.
Mm.
If you are running EIGRP also, and there are certain attributes which I will come back to later,
Yeah.
if they match, then
Mm.
we should become neighbors.
Yeah.
Then we should become adjacent. That means we should start exchanging information with each other.
Yeah.
So the first thing
Okay.
that goes, step one is discovering the neighbor.
Yeah. Good one.
Now,
So
discovering the neighbor, it means, Yane, you will send a hello packet.
yeah.
Now, what is under the hello packet?
The
The
neighbor.
first,
Yeah. Carry on.
yeah, the first thing that under the hello packet is you have a few things like the ASN number, which is it has to be the same within your network. All the uh, EIGRP routers that you want to
Yeah.
become neighbors with each other, they should share the same ASN number.
Yeah.
Okay. I think then there is something called the hold timer. This also has to be the same. Not same, it does not have to be the same, but this is one of the attributes of the hello packet.
Mm-hmm.
Then you have authentication. You don't have
And
to get into the details for this right now. I'm just giving you a gist of it. Then
Yep.
you have
yeah.
Yep.
the metric values because it's very complicated. You can write books on just each one of them.
Yep.
And then isn't the dead timer also part of the hello
Hello
packet?
timer. Yes, hello timer and hold timer.
Sarah, I
Okay.
think for EIGRP, the timers need not match at both the
No,
ends.
no,
So let's
no.
let, let's put that down. So for EIGRP, oh sorry, let me
The
go.
difference between EIGRP hello timer and OSPF is um, a hold timer. I am telling the neighbor that if you do not hear from me,
Mm.
um, let's say 20, I forgot the default timers. Let's just keep it as 15 seconds. If this is my hold timer, if you do not hear from me in 15 seconds, cut down the um, relationship between each other. With OSPF, the neighbor itself decides when the other end will go off, switch off, or you will lose the neighborship.
Mhm. Good one. Excellent. So first thing, we discover the neighbors. How do we discover the neighbors? They send hello packets to one another.
Yes.
So when they
Hello,
send
Pat.
hello packets to one another, some values must match, otherwise they're not going to form a relationship. So depending on, you know, the values in the hello packet that you're sending to me, that will determine if I'm going to form a relationship with you. And what that relationship simply means is that I'm going to tell you what I know. Like Sarah said, it's routing by rumor. So for you to learn about the routes, another router has to tell you, like this one. For this guy to know about network two, for this router to know about network two, this router has to tell him. And for this router to know about network one, this router has to tell it. So basically, they're like, we will form a relationship where we can share this information that we know with one another. So it will depend on, the autonomous system number that Steve mentioned, the IP address and the subnet mask, that's important, must also
Very,
match.
yes.
Yeah, because
Yes.
they must be on the same network, and not only must be on the same network, they must have matching subnet mask. So
Yes.
what does that mean? If you've got, 192.168 is, 0.1 slash 24, and then you now go ahead and have on the other one, 192.168 0.2, then slash 25, they're not going to form
Yes.
a relationship, except because
Same
that's like, yeah, that will help in terms of troubleshooting later in case you see something like that in the exam. So first of all, the network and the mask must match before they form a relationship. Next thing is the ASN or the autonomous system number. Yeah, the autonomous system number.
Here's number, yeah.
Must match. What else must match?
Um, I'm not, I have to look into this. I've
Okay.
actually forgotten
Yeah,
about
go
the
on.
whole timer,
Yeah.
but whole timer is a part.
Authentication.
Good one, exactly.
It's
Good one.
authentication. Yeah.
So if you've got authentication running, authentication must match. There's one other thing that must match.
The source IP neighbor's hello must be the same subnet of the local router's interface.
Yeah, that's this one. That's this
You
one.
have to remember the network thing, the mask network. It
Yeah.
means that it belongs to the same
It
network.
must have
This
the same
is
AS
this,
number as well.
Yep.
this works
So
for both
that,
OSPF and EIGRP.
yeah. So that's this
You got
one.
all three of them. What else is there?
Yeah, there's something else.
Yes, there is metric
Good one.
values,
Good one, Sarah.
which is the most important thing. You have something called K values.
Yeah.
I think it is 0100110 something. It has
Yeah.
to be the same on all the routers
Yeah.
that are
That's out of the scope of CCNA though. K
Well,
value
no,
is
not
not-
really. Actually, you know,
Not
like,
really.
no, not at all. Because I did my, when did I do my, I did my CCNA training in London. First one I did was in 2009. And even then, my instructor was teaching us about this one really heavily. Because I remember that we spent like, you know, a lot of minutes, a lot of time talking about K values and talking
It's
about
very
that on this one.
it's very
It's not
deep,
going to be
but
on
if you
your
understand it, so
Yeah.
many things become easy for you.
Yeah.
I'm still working on it, so I don't know much.
Yeah.
You won't see it on your test.
Yeah,
That's all.
yeah, exactly. Yeah, you won't see it on your test exactly. But then the other thing though is that in the real world, it's definitely useful. No, no knowledge in IT is useless. So,
Oh, yes, no knowledge is enough, rather, we should say.
Yes.
yeah. Okay. So now we already know. So now we know how they're gonna form a relationship. Now okay. So Powell is saying something. No need to match. It tells the other router just to keep it for long. So network in IPv6 doesn't have to match. Okay. Powell is bringing. Thanks very much. It's really nice to have you around, Powell. David, what in the case of IPv6, it was based on FE address. So network in IPv6 doesn't have to match. IPv6 only. So does anyone want to comment on that? Because that is way over my over my head at the
Me too.
moment.
I haven't touched IPv6 for ages.
Powell, that's like a very very useful information. That's a really good one to know. So basically on IPv6, what Powell is saying is that the network doesn't need to match because it just works based on the FE address. But yeah, I think I need to study up on that. I tell you.
Me too. I
Yeah.
need to pick it up soon.
Yeah. Thanks very, very much. Okay, so now they formed the neighbor relationship. Um, so now how are they going to begin to share messages with one another about what
Okay,
I
so
know about? Yeah, carry on.
the first step that we probably you could write it somewhere,
So
so
let me
everybody can.
cut this one and then move this one to the other whiteboard.
Yeah, the first step
Yep.
is discovering the neighbor. So this is basically like, yeah, we know we exist.
Mhm.
So the next step is, are we ready to exchange information with each other?
Mhm. Yep.
Okay, step 2 is exchanging the topology information.
Mhm. And how does that work? So we know how they discover the neighbor, how they form the relationship, what needs to match. So exchanging topology information, what's going on in that stage?
Now, there this the exchange of topology information with EIGRP is done with update messages. Okay, now these update messages are reliable messages. Do we remember TCP, reliable connection, where you get an acknowledgement back,
Yep.
and how it differs from UDP?
Mhm.
Same thing. EIGRP is
RTP.
reliable.
Yeah,
Yeah,
good one. Excellent, excellent, Mark.
RTP.
this is
Yeah.
a real-time protocol.
Yeah.
But this is connection-oriented. Like,
Reliable transport protocol.
yeah, I'm sorry. Yeah, real-time protocol is with voice.
Reliable transport.
So what did you call it again, Mark? You said reliable transport protocol.
Reliable transport protocol.
Yeah, and that's RTP. Thanks very much for that. Useful information.
Okay.
Yeah.
Yeah.
Can I ask something?
Yeah, carry on,
Un-
Petros.
Yeah, under point number 1, we discovering the network.
Yeah.
Is it not also where the election process is?
What election?
Yeah,
The
election.
feasible, the feasible successor and and all, yeah.
No, because we have not exchanged any topology information as yet. This is
Okay.
just saying that it's like acknowledging the existence of each other.
Hmm.
When you have topology information exchange, which is step 2, then
Okay.
is when you choose the best path, and that's where
Okay.
you have the feasible
The
successors.
election process. Okay.
Mhm.
Also,
So
step 3 should be the election process.
choosing the best path, yeah. You
Oh,
would
okay.
you would actually say election process with OSPF, or
OSPF.
you can use election with the router ID
Mm.
election, or you can say DR election. This is
Or like,
choosing the best path.
yeah. Or spanning tree protocol
Mm.
as well. There's an
Uh,
election.
that horrible loopy concept, yeah.
Yeah. Okay.
Okay, yeah. So as he mentioned, RTP is reliable transport protocol. This is connection oriented, like TCP, where
Mhm.
you send an update, you have an acknowledgement back,
Mhm.
right? So instead of using TCP, EIGRP has its own custom protocol called Reliable Transport Protocol with protocol number 88.
Mhm. Yep.
So yeah,
Yeah. Good one.
so what happens is you're going to send an update. Now the updates can be sent as multicasted or they can be sent as unicast. It's a whole thing that you can get into later, not right away.
Mhm.
And what does an update contain? It's an update packet. If you fire up Wireshark, you can see this packet.
Yep.
Uh, this will have the prefix of the prefixes, whatever networks you have in your. For instance, I am connected to A, B, and C, right? So B will send to C the prefix of A.
Mhm.
Yeah,
Yep.
and then you have other stuff like bandwidth, delay. These are the composite metric values, load, reliability, MTU, hop count. It's a lot of stuff. There are some external attributes, but all these make up an update packet. Basically, it's telling the next router the information that I have
Mhm.
in with me.
Mhm.
So every router is going to be exchanging these update packets with each other
Yep.
with acknowledgements.
Yep.
And that's how the uh, topology table, neighbor table, the topology table gets populated.
Yeah, Mark, what's your own understanding of that? So in terms of like, so after the routers have formed an adjacency, they form the relationship with one another. So they're sharing in terms of sharing the route. How does the route sharing happen?
Root sharing?
Yeah, between the router. So basically, you've got one router that's running EIGRP, the other router running EIGRP. How
Oh,
do
you
they
have to have a
share?
redistribution router. If
What?
you have if you have EIGRP and then you have OSPF, is that what you're asking me? How
No,
do you combine the two?
no. So in terms of like this one, so the thing I'm just asking what's your own perspective of what because Seva has given us our own perspective of how this happens in AIGRP in terms of the
I
update
think she's
messages.
pretty spot on. I mean,
Yeah.
the only things that we're missing are like split horizon and route poisoning, but those are more like features and kind of rings and bells, you know what I mean? But I think she's pretty spot on as far as the process is concerned.
I mean, excellent, really, sir. I mean, even I'm really learning a lot from all the explanations and everything. Good one. Okay, so we go to number three.
Yeah,
Uh,
so what we
Weebly,
have
come here.
established with yeah, what we have established so far is that after step 2, once all the updates are exchanged, you now have the topology table, EIGRP's topology table.
yeah, okay, so that brings us to something. EIGRP has three tables. So what are those
Yes.
three tables?
The
Or
neighbor
usually,
table.
well, I won't say has three tables because the third table actually belongs to the router, not really to the EIGRP. Routing table belongs to the router, not to EIGRP. But okay, EIGRP uses three tables. Let's just put it that way. So what are those three tables?
The
The
neighbor table, topology table, and the routing table.
So what will you find in the neighbor table?
Hey guys,
in the
I really want to stay, but I gotta go to work now. So thank
Ah,
you.
okay. No problems, man.
We'll be in touch.
No problems,
All right,
man.
man.
Yeah,
Take care.
bye.
Okay.
See you around,
Sweet
man.
Mark.
See you, Mark. Yeah, so we've got neighbor table. We've got. No, I just didn't say. We've got neighbor table. We've got
Topology and the routing table.
and the routing table. So what will I find in the neighbor table?
The neighbor table would contain all the neighbors, I mean directly connected neighbors, where it can share hello packets.
Yeah, okay. Contains information about directly connected routers, right?
Yeah.
I'm a bit confused, I'm so sorry. Who am I speaking to before this? David and the other gentleman? That's Asad?
Yeah, this is Azad.
So
Asad,
Assad, yeah, so Assad is the one speaking now.
right? Yeah, yeah,
So
okay.
yeah, then Mark before, then we got Mr. Gorgeous.
David.
I like the
I'm
name.
gonna change my name.
It's a really no, don't change it, man. It's a really nice name. I like it, man. Stands out. Okay, yeah. So we got the neighbor table, topology table, and then we got the routing table. So what's in the topology table? And Petros, you want to try to go for that. So what's in the what we'll find in the topology table?
On the topology table.
Mhm.
Um.
So what's the thing? So in the neighbor table, we'll find information about directly connected routers or the routers that will formed neighbor relationships with. So what about in the topology table? Yeah.
Um.
Assad, do you want to help? You want to help a bit? So
Yeah,
what we'll find? Yeah, carry on, please.
I suppose the topology table would be the repository of all the router. Mean to say, it will have the backup route as well as the current route, which would be fetched from the topology table by the routing table. The routing table would have all the latest best path,
Mhm.
whereas the topology table would have the best path as well as the backup path.
Yeah,
Is what
excellent. So, in other words, what Assad is saying, Petros, just to make it clear
Yeah.
to you, is that let's say there are two routes that you can use to get to network two. Let's say one
Yeah.
route is maybe there's like another router here, and this router can also get you to network two. So if you look in topology router, topology table of this router here, what you find is that if I go, let's call this one number one and let's call this one number two. If I want to get to network two, I can go via router one. And also if I want to get to network two, I can go, oh sorry, I got one on one. Let's call this 12. I can go via router 12. So it will have all this information in its topology table. So it's building like
Okay.
information about the whole topology, the whole network. But then if you
Okay.
now go down in the routing table, which Assad will help us with again, if we now go down to the routing table, uh, what are we going to find in the routing table? So Assad, can you help us with that? What we will find in the routing table?
Yeah, sure. A routing table would have all the best path to all the routes. As Sarah has said, we mentioned the network and the network IP, and it will have the best path to the networks.
So
And then
yeah,
which
carry
route
on.
does it take as well?
So
Um.
what did you say, Petros? Carry on.
Which route it takes? Which interface does it? Uh,
Y-
which interface does it use to reach the other network?
Exactly. Exactly. So
Mhm.
basically, the other one is going to be there is like the information about all the routes I've learned, the whole
Yeah.
picture of the network that I know of. But the routing table will be
Okay.
like, okay, but this is the one I'm selecting that I'm going to be using when it actually comes to routing. I mean, you should
Okay.
watch the video from like the last time. Sarah accurately explained the last time about, the different processes before, routers send packet out, the routing process, the switching process, and all that stuff. Okay, so good one. So we've got all these. So let's do just a bit of lab part with this one. So I've got two routers here, just something basic, just to help us out with the things that we've discussed so far. So we've got two routers here, router 1, router 2. I know for some of us this is just, something revision and stuff like that. But for router 1, router 2, router 1's got like all these networks, 192.168.1.0, which will just be loopback interfaces, and router 2 has all these networks that it knows about. So what we want to do is we want to get both these routers to share this route, and then we want to, capture what's going on through Wireshark to see what to be able to understand it a bit much more, just to see what we've described so far. So can someone help me? So with this one, so let's bring up the interfaces so we can see. So if I want to, what are the EIGRP commands for configuring EIGRP?
Yeah, it should be router EIGRP
Router EIGRP, yep.
and ASN number.
ASN number, yep, good one. And what's the significance of the ASN number of the
Uh,
autonomous system number?
it should be the same across all the routers which you wanted to be in the same network. Only
Good.
then it would communicate.
Yeah, good one, excellent. So basically, if you've got like a bunch of routers that you want to communicate with one another, you have to put them in the same autonomous system number. You have to give them the same autonomous system number. Otherwise, they won't communicate with one another.
The ASN number,
Yeah.
it allows you to run multiple EIGRP processes. So you can have one ASN2, completely different entities within your network.
Good.
They're
Good.
unrelated networks, yeah.
Yeah.
Okay.
Yeah. So that's like one advantage too. Nice to
So
know that.
OSPF, it's areas.
Yep. Okay. So let's go. So if we go router EIGRP1, okay. Now we've got EIGRP. Oh, the other thing that we need to do is we need to actually start capturing this one and then start capturing the other one so we can actually see what's going on. Because the moment, now we've enabled EIGRP on the router itself, but then let's just cut that. We go EIGRP and let's capture this one also. Okay, yeah, that's enough. Okay, so then if we'll go, but then now we're not seeing any EIGRP traffic. Why is that? Can anyone say why are we not? So, well, Jerry, so why we've enabled EIGRP on router 1, but we're not seeing any EIGRP traffic yet, even though we've enabled it with the command that Assad told us, which is accurate. So why are we not seeing any traffic yet? What else do we need to do? Jerry said you have not enabled send hello. So how do I enable send hello? Network command, excellent. And so what's the significance of the network command? What is the network command identifying to me? Or when I'm typing in my network command on my network, let's say I'm in a production environment, labs department has just requested for a new network. I've created this new network. I want to add it to EIGRP. What will guide what will I be typing? What is the network command? What is it identifying? Kevin,
Okay, so
yeah, carry on, Sarah. Carry on.
No, Carrie, please, hi, Carrie, go ahead. I thought nobody was answering, so I was going to yap. Go ahead, please.
Yeah. So Kerry, yeah, I'll pause with that. So so now we've enabled the IGRP. Jerry said, and now the reason is because we've not enabled the sending of hellos, which has been wonderfully described earlier. Interface or group of interfaces participating in EIGRP. Excellent. Can someone help to break that down a bit? So interfaces or group of interfaces participating in EIGRP. What does that mean?
Okay, when you give a network statement, as I'm trying to think of a mask over here. Right, your router has two interfaces that belong to the 192 network, and the rest of the two interfaces belong to let's say 20 network,
Yep.
okay?
Mm-hmm.
Subnetted, VLSM, whatever. When you give a network statement saying network 192.168.1.0 with a wildcard mask 0.0.0.255,
Mm-hmm.
this is going to enable EIGRP process on only the interfaces that fall within the range of 192.168.1.0/24. That means
Yep.
.1 to .254.
Yep.
So your other interfaces, which I said your router has 20 network,
Mm-hmm.
EIGRP is not going to be enabled on that.
Mm-hmm. Good one.
Is it?
Excellent. So I asked the question in the chat window because Gemma said it will advertise the network for network adjacency. So what I'm so my question to Gemma will be, does it mean that the network segment is identifying the network that will be advertised? Is that what it's identifying? Oh,
No.
yeah. So Sarah,
It's
yeah, you
enable
wanted to answer that, yeah.
it's enabling EIGRP on whatever network statement you have given. Those IP addresses, if they are configured on the interfaces, it's going to enable EIGRP on that interface. If you give a network statement, network 0.0.0.0, I think,
Mm,
it enables it on all the interfaces,
yep,
irrespective of what network you have.
yep. So let's go back to interface. It
Yeah,
from
Powell, in case of passive interfaces, you are not going to be exchanging anything with them. So, yeah, not there. You're
you
not
know
even selling.
yeah, you know what happened to me now? I was typing interface it because we use Brocade at work. I've moved back to typing Brocade commands. Because in Brocade you go Ethernet. This one, yeah, sorry. Interface fast Ethernet 00. Okay, yeah. So let me just quickly give these IP addresses. So let's give this one 10.1 dot um dot 10.1 dot 1 dot 1 255 255 255.252. Ah, forgotten. This is... does anyone else work with multiple vendors?
No, not
Why you have to why you have to know like different command ranges
Oh,
for
that's
different ones?
why? Okay.
Oh.
You are not loyal to Cisco.
No, no, my company unfortunately the money. So yeah, we use Brocade. We do use Cisco, but we use
Okay.
Brocade too. Okay, so okay, we've got this one on this interface. Yep, and that interface is enabled. And let's do the same on the other one. Interface fast 00 IP address 10.1.1.2. Okay, so yeah, so we want to enable EIGRP. We want to identify the interfaces that EIGRP to work out of. So now this interface has this IP address. What will be in my network statement that I will use?
It's up to you how what you want to give. You can say 10.0.0.0 with prefix with /8, but you
Yeah.
want to be very specific
Specific,
here.
yeah. So if I want to be specific and say I only want to enable it out
This is
of this interface. So does anyone want to, anyone, let's see who else is online. Petros, do you want to assist us with that? Or Petros or Kerry? Do you want to assist us with that? So how do we identify, you know, this specific interface? So we say the network statement is to identify the interfaces that AIGRP2 will operate on. So we don't want to, be wide. We want to be specific and say we want you to operate on this particular interface alone.
Okay. Okay. I think the statement should be just network
Yep.
10.1.1.0.
Dot 1.0. Okay.
Yes, and the wildcard
Oh, sorry.
if I stand to be corrected.
No, I mean, yeah. So network 10.1.1.0. And what about the wildcard? What would the wildcard be?
Uh, it would be a 0.0.0.255.
.255. Is that accurate?
No, the 3, sorry.
.3. Good. Excellent. And how did you come to the conclusion of .3?
Because with wildcards you just minus the
Invert.
2
Yeah.
factors. You just inverse, yeah.
Excellent. Excellent. And then once we do that, we've enabled. Now let's see what's going on. And here we go. Now we can see our hello
Yes.
messages being sent out from the interface, because now we've identified EIGRP can start operating out of this interface. Now it's operating out of the interface.
Just to add again,
Yeah.
that's 224.0.0.10.
Yeah.
So I stand to be corrected. I believe that is the multicast that EIGRP uses.
Does anyone want to expand on that for us? Assad, do you want to expand on that for us?
Yes, it's multicast address because when you enable a process on EIGRP, right? Why do we need a multicast in this case? Think about it. Do we know the IP address of the other side, or do we know anything about the other side? No. The other side just comes up, so you are going to send it anonymously to everybody, whoever is out there and is willing to form a relationship with you will. So that's why.
So basically, this in a way, it's sort of like an ARP message.
Well, the ARP is to retrieve, to resolve an IP address. In a way, yes, you can say that.
In a little way, yeah. In a little way. In a little way, in terms of like, an ARP goes out to everyone, but this one is saying anyone that is listening on this address. Now, by default, when you buy a Cisco router, they've programmed it such that by default, if you enable EIGRP on it, it starts to listen to anything that is addressed to this address. So they've programmed it that way. So instantly, when you enable EIGRP, it starts to send messages to that address. So, and you enable EIGRP on this other router, they've programmed this in such a way that it starts listening on that address. So any communication going to that address, it's going to hear it. And then it can, carry on, please.
One more thing I will add to this is, initially, like I mentioned, the second step that we have where you are exchanging the topology information. So the updates are going to be sent as multicast or unicast. Okay, but initially it will be I've just forgotten this bit, but yes, this I remember. I lose a route to myself and I have to give you the information, or I add on something, then because I already know about you, it will be a unicast update message. But before I know anything about you, it's just going to be a multicast.
Yeah, good one.
Okay.
Good one.
Yeah, but on this IP that we're seeing here, which is the 224, I know it belongs to a multicast for EIGRP. So I just wanted to make sure, am I seeing
You're absolutely correct.
multicast?
You're absolutely correct. Yeah, you're absolutely correct.
I'm saying for OSPF is .5 and .6.
Yeah.
DR and BDR.
Yeah.
Okay, yes.
Yeah. So basically, it's like the concept that Sia mentioned. I remember that when they come out, doesn't know the address of, which we should be talking to. So you can either send a broadcast and say to everyone on this network, but that would be inefficient, right? But many routing protocols make use of multicast addresses where they've been programmed to listen on that address. So all another router has to do is send a message to that multicast address, and anyone that's listening on that address will be able to receive it and respond to it, of course, if all the conditions align together and all that. So now we have this router sending this EIGRP message, this hello message to this address. And again, like what we've discussed earlier, let's see how accurate we are. What we've discussed earlier about the content of the EIGRP message. So what do we find in there? Let's say the parameters. Yeah, we can see the metric there. Yeah, the K values that Seva and Assad mentioned. Here we go. You can see the metric there. What else can we see?
The whole timer. This is the
good one. The
this is what's going to. I'm telling the router next to me, my neighbor, that this is 15 seconds, right? Yeah. You wait for 15 seconds. If you do not hear a hello from me within 15 seconds, consider me dead.
Yeah. Yeah, excellent.
In
And
case of OSPF, it's the other way. The router decides when it needs to consider the other side dead, and it has to be equal.
yeah, exactly. And
Not
then yeah, the one we mentioned also, the autonomous system number. It says,
Yes.
well, this is my autonomous system number also. Yeah, okay, good one. So then let's go ahead and do that the same thing for this other hand. And let's go
Uh,
say, yeah,
David,
carry on, please.
yeah,
Yeah,
I have a query here. When you mention IP address,
yeah.
network, and do we have to mention the wildcard mask or the subnet mask? Which one we have to mention here? And what is the difference?
You mean
I actually tried mentioning the subnet mask as well as wildcard mask while configuring,
mhm.
but I couldn't identify any difference. Do you guys know anything about it?
You mean the ones that have to match before they form a relationship?
I
Yeah,
think
Or which one? I
yes.
mean, I'm trying to understand the question. Sorry, I said. So do you mean that the values that have to match to form a neighbor relationship? Is that what you're referring to?
Not that.
Yeah.
In You have mentioned the IP address and the wildcard mask, right? I
Yes.
mean,
yeah.
just now. Yeah. There, do we have to mention the wildcard mask or the subnet mask in case of EIGRP?
In the
In
network
OSPF, we
statement,
mentioned the
is it
wildcard.
is it in the
Yeah.
network statement you mean?
Yes.
Yeah.
Yeah. So
Yeah.
it's the wildcard mask. So for example, if I go back to this
Okay.
one, if I go network
Yeah.
10.1.1.1, you can see EIGRP wildcard bits. So it's expecting the wildcard.
I think just to add on that, Asad, I think when you're using the wildcard, not the wildcard, I mean the subnet
Subnet.
mask, it's when you're being specific to a particular host.
But
Like when you,
even if you're using like even that one
Okay.
like in that case, what you would do is let's say you want to be specific to a host. You can say um like do you mean like maybe I want to say 10.1.1.1? Yeah, exactly. So I can say 0.0.0.0.
Okay. Correct.
So which means I'm gonna match exactly this one.
but isn't that still using the wildcard mask by saying zeros only
Yeah,
without saying all 255s?
yeah, it's still the wildcard mask.
Or, when I say 255, all 255s, do I say, am I saying the exact host, or
So
when I
let's
say
so let's
zeros
go back
only?
here. So let's go back to this. This is the network statement that we used, right? So let's
Yes.
remove this network statement. Yeah. And then what we should find out is that no more LOs are sent out of that port, right? So let's go back to this one and let's go to that network statement again. And instead of 10.1.1.0.0.0, so let's say 10.1.1.1, which is the IP address of the interface that we want. And let's try to
Yes.
say 255.255.255.255. What impact will this behavior mean?
Will that be a broadcast?
You, yeah, it's close, but what else? What other impact do you think it means? Like, look at what Powell's answer mean.
Yes.
255.255.255 means that all interface participates in EIGRP.
Okay.
So basically, it's expecting a wildcard. If you put it, it's going to treat this as a wildcard. You get the point?
Mhm.
I'm not sure is that clear, or do we need to? Is that? I'm not sure. Assad, did I just confuse you, or is that clear at all?
Yeah, it's clear. It's
Yeah,
clear. I mean, I just had this doubt about do we have to mention the wildcard or the subnet mask? So yeah,
yeah,
it's clear.
yeah. I mean, to my
Thank you.
understanding, I'm not sure if it's different. And Powell will know. Powell, is it different for the iOS 15? iOS 15 does it take subnet mask now um instead of
Uh, Asa, just to check again, in what you're saying,
hmm?
so is it possible to say 10.0.0.1 and then you say 255.255.255.0? Will it allow or it say no, hold on, it's
Okay,
not
so
possible?
let's do that. So let's go um router EIGRP1 and let's go network 10.1.1.0, right? then 2i5, 2i5, 2i5 dot 0.
It allows.
Yeah,
But
this
let,
is
let's
what.
let's do this.
Yeah.
Let's do show run and let's see what happens. Let's see what it's showing in the in um running config EIGRP. Yeah, so it converted it itself. Okay, I see what
Oh,
you mean,
okay.
Assad. Okay, so what
Mm,
Assad is saying is that it's going to automatically convert it by itself.
okay.
Yeah, good one. Good point, Assad. Good point.
Yeah.
So,
Thank you.
Powell said, I never noticed that, but that's a really, really good point. But then again, Assad, will you advise that if someone is going for an exam, not to try to use this method?
Yeah. And yeah, we have to go with the
With
syntax
the yeah,
using
Mm.
wildcard mask.
yeah, yeah.
Yeah,
You
just
don't, you do not
just to
have
be sure.
configuration.
Sorry, just
NA
to be
even for
sure. Sorry, Sarah. Just to be sure, on both EGRP and OSPF, we use wildcards.
Yeah.
yes.
Yeah.
Yeah.
Okay.
But then
Yeah,
it
just want to be
converted
sure.
this automatically from a
Yeah.
subnet mask to a wildcard mask by itself.
Because what
Correct.
it means is 0 means I care, and
Mhm.
255 I don't care. So 10.1.1 has to be fixed.
Yeah.
After that, because what are you specifying here? You are giving
Someone is breathing
10.1.1.1.
heavily. I'm not sure. Let's.
Has
Yeah.
Yeah.
So,
No. It's still having breathing. I think maybe
to-
Assad from Assad. Okay. It's Assad. Assad, are you jogging? Are you on a treadmill? Yeah, okay, yeah. So basically, I mean, Sarah, what Assad pointed out to us is this. Look at the network statement that we used. We used a subnet mask instead of a wildcard mask. But
yes.
then iOS automatically converted it, if we look at our
To
running
the-
config, to a wildcard mask.
Yes.
So that's
Because
yeah, carry on.
that's the way iOS is configured to do. I know there's a reason behind it. I have forgotten, but it does, and that specifies that the network is 10.1.1
Mm-hmm.
dot 0 slash 24.
Mm-hmm.
So the last octet, I don't care. It can be anything, but enable EIGRP on anything dot from dot 1 to 254.
Mm-hmm. Okay, let's see. Powell is saying if you use network, it's always wildcard mask to my knowledge. But more often, instead of network, you enable EIGRP on interface. Yeah. You can
Yeah.
even run EIGRP version 6 with address family IPv4 command, and then you have no choice than enable EIGRP on interface. Powell, don't worry. I mean, next week we'll be going into EIGRP version 6 next week, and I tell you, I'll come really, really hammed for you. All through the week, I'll be reading AIGLP version 6. Don't worry, I'll be ready. I'll get my Cisco out, my CCNP routing book out, and and I'll be reading AIGLP version 6 all week. I promise you that. So next week we'll be doing we'll do that. So Power says you can run AIGLP version 6 with address family IPv4 command, and then you have no choice than enable AIGLP on interface. There's no network command. I don't understand that. I really don't
yeah. No,
understand the point.
I do get them. I
Yeah.
think on IPv6 you
Yeah.
don't give out the network statement 10. You just enable IPv6 on the interface,
Mm-hmm.
and you just say the EGRP1, and then just say IPv6, and then it will advertise on that interface.
Mm-hmm.
Yeah, I think that's what he's saying. You don't give a network statement on
So,
IPv6.
but then the other, I mean, the question that I'll be reading that this week. But then the other thing, the question that will come up will be, I know IPv6, is much more intelligent and in the way it does things. But then
Hmm.
how will that translate into, okay, I have to configure passive interface, I guess, if I don't want it to operate to start sending hello packet out of particular interfaces, I have to enable passive interfaces. Is that it? Is that what you're referring to? Or am I getting you wrong? Assad, I know you're CCMP, help us here. So, so Powell is
And
bringing up EIGRP version 6. Like, if you want to enable EIGRP version 6, like, is it saying that you just go EIGRP version 6 and then basically it enables it on our interfaces running version 6? Is that what you're referring to?
remember when you're giving network statements, you need to go to an interface and you say EIGRP1 network,
Mm.
and then you give the statement. Now, if you're already on the interface, you can just say advertise EGRP. I think that's what he's trying to say.
Ah, okay, but hold on. Okay, then it says you can run EIGRP version 6 for IPv4. So Powell, help me out. So if I want to run EIGRP
Okay,
version 6
yeah.
for IPv4, how do I do that on this particular? So I'm on the command line now. What do I need to do? Just type it. We'll see in the chat window. What do I need to do? Okay, so let me go back to, let's go to network statement that we used. Where's the network statement?
Ah,
And let's remove it.
there's the answer.
So let's go no network. So then it should stop sending hellos now. So we are at 4:30 here. So let's go back to this one. So but you can run AIG. So then if I go back and go exit
Does
and go,
does the iOS support IPv6?
yeah, it does. No,
Okay.
at least to my knowledge, no router EIGRP1. Okay, so you can run AIG with IPv6. Okay, let's go IPv6 router EIGRP. Then address family. I guess by address family
Now you need to give it, I think, the autonomous number.
system. Okay, if I give it an autonomous system number, um, yep, enter. Okay, okay. Um,
There's the
somebody,
first.
somebody help to remind me of this one. How do I enable IPv6 on Cisco iOS?
It's already done it for you. Oh, it's not enabled.
Ah, yeah. Thanks very
You
much.
should-
You
Thanks.
forgot.
Thanks very much. Okay, yep, good one. So I've
Yes.
got that running now. Okay, so what else? So basically, does that mean that it's operating on the IPv4 interface now, Powell? Is that what you're talking about? Now? Yeah. So does that mean it? So what else do I need to do? You said I can run EIGRP version 6. So now we've enabled
I,
EIGRP version 6 now.
yes.
So how do I
But
get
I
it to
think
work? It says I
I,
need help type. Okay, so if I type question mark, okay, yeah. Okay.
so. Okay, I don't know if I'm going. If I think Powell will correct me or Assad.
Yeah.
Don't you, for you to enable EHRP to run,
Mm-hmm.
don't you go to the interface and then you set it, you set IPv6 from there, from the interface, from here, because I think after here you go to the interface and you enable it from there.
Yeah, no problems, Power. Yeah, I mean, for IPv6, I'm not sure. You know,
Hmm.
I'm not sure. Sarah Assad, are you sure? I'm not sure regarding that. Uh,
Can you go to the interface and let's
yeah.
see the help from there?
So yeah, so I put the question mark on this interface so you
Hmm.
can see all the commands
Oh,
available here. Because that I mean that sounds interesting. You know, even if it sounds interesting what Power said that we can run AIGRP version 6. No problem, Sarah. No problem. That we can run an EIGRP version 6 on
no,
IP version 4.
currently you under the what's this? IPv6 router EGRP
Yeah,
command. You're not in the interface.
yeah. So do I need to exit out of this? Is that what I mean?
Yes, yes. And then go to the interface that we need to advertise.
Okay. So let's go exit. Okay. So if I go to interface fast 00, yeah,
Yes, and let's see the question mark.
question mark.
Because I know from here you just, there's a command that you give out and then it's done. You just do a simple thing and then you press enter and it's complete. Can you go more?
Mm-hmm.
Uh, okay, EIGRP interface specific command. Yeah, and let's try each. Yeah, man. I'm just trying to think of the command. I don't,
Jerry
Yeah,
said, what
yeah,
are
I
you trying to
need
do? So,
I need
so
help from you.
what happens? What we're trying to do is that Power brought up a point and said we can run EIGRP version 6 for IP version 4. So we're trying to run EIGRP version 6 for IP version 4. So because we just thought that would be interesting to see. Um, okay.
Okay, Powell, I just want to ask Powell.
Yeah.
Powell, what is the command that you give to enable IPv6 on the interface to start routing?
But then the thing is, what if I don't want to enable IPv6 on the interface? Because I want to keep
Oh,
my
okay.
network as IPv4. Yeah, but then again, another question that will probably pass to Power, so I can see documentation. I mean, we'll be going into EIGRP version 6 next week because again, EIGRP version 6 is one of the things that I noticed when I was looking at the new Cisco curriculum for CCNA is that it also has EIGRP version 6. Am I right? It does have
Yes.
EIGRP version 6. So it's one of the things that it's in the new curriculum. So it's one of the things that we'll have to study also. And I'm supposed to be studying for my CCMP route, but I've not gone because
Yeah,
of
you have to
because
go
of
back,
work.
but yeah.
Yeah, and stuff like. Okay, yeah. So basically, I mean, we'll be discussing IGRP version 6 next week. So yeah, IGRP autonomous system address family IPv4. Okay, so if you're just saying if I go out of this one, and if I go exit, and I go address, no recognize command, or if I go back to this one and there's no address there, so it can't be from there. Yeah, okay. So what we'll do actually, Power, we'll be studying EIGRP version 6 next week. So yeah, no problem. We'll be studying EIGRP version 6 next week, and I'll be doing like a lot of research and stuff into that, so we can be able to discuss that in more details. But if you can just help us quickly a bit, you said we can run EIGRP version 6 for IP version 4. Is there any difference between EIGRP version 6 and EIGRP version 4, or is it typically the same behavior? Ah, okay. Jerry says it's a CCMP. Yeah, I know. But then here's the other thing, Jerry, is that like what we said earlier, no knowledge in IT is lost. So even though you may not necessarily like use it for your CCNA, but it's a good thing to know. Who knows? Maybe at work tomorrow, somebody will just walk up to you. Who knows? And say, Jerry, what about EIGRP version 6? It happened to me before. There was an interview that I went for, and it was basically a discussion that I had with my friend like a couple of days before, and they were asking me questions about it in the interview. So yeah, could be useful one day. I heard that EIGRP process was rewritten and more optimal, but concepts stay the same. That would be interesting. So we'll be discussing that next week. So we'll go into more details about that. Okay, good one. So let's go back to version 4 now, and let's go router EIGRP 1 again, and then go for the network statement that uh, Petros gave to us, which is the network. Um, there we go. And then we run that, and then all of a sudden we have our packets, our hello packets, we start sending again. Okay, and then we do the same on the other router, and then what should happen? So if we go router EIGRP 1 and then do the same network statement. And then what should happen is that, yeah, instantly we see a message that says neighbor adjacency is up. So if I want to see this neighbor relationship, where do I look? If I want to see this neighbor relationship that has formed between these two routers, where do I look? Asad, you want to help us with that?
Yeah, it would be show EIGRP neighbor
Show EIGRP or
neighbors
show EIGRP neighbor.
neighbors. No, maybe topology.
Yeah, I think he wants the autonomous system number first, does he?
Yeah, correct.
Show, no, that doesn't work.
No.
So how else? Is there any other, any, which way, if I want to see the neighbors of this router, how do I find out?
So show CDP neighbors.
No, not CDP neighbor. So I want to see because it formed neighbor relationship with this other router, between router 1 and router 2.
Will it be show IP
Show
EIGRP
IP.
neighbors?
Show IP. Yes.
Yeah, good one. Show IP IGRP neighbors, then I can see this
Yeah.
one here. Okay, so then we mentioned something when we were discussing. We said that there are three tables that EIGRP uses. So this is the neighbor table, right? So how do I see the topology table?
EIGRP topology.
Show IP EGRP. Yes.
EIGRP
Topology.
Topology.
Yeah.
topology.
There is a bit of a difference between. I will explain. The
Yep.
topology, like I said before, there is a whole concept of a backup route and the main route, which is called a successor in EIGRP.
Yep.
So there is this whole condition that the backup route has to meet. It's called a feasibility condition.
Mm-hmm.
Okay,
Yep.
which is actually a way, like without getting into details, because it's
Mm-hmm.
a very loopy thing.
Mm-hmm.
It's a way that any route which can create a loop is not going to be shown in the topology table,
Uh-huh.
right?
Yeah.
So let's say you have 3-4 ways to reach a network. Two of them are is there's this whole split horizon thing. It's going to create a loop that will not be shown here. To see every possible way to reach a destination, you can do show IP EIGRP topology
Mm-hmm.
all links.
Mm-hmm. Oh, okay. So let me go back. I'll go back to that. So that will show me all the links.
Everything, yeah.
Yeah. Okay. Let's go.
Every possible thing that we have learned.
Okay. And so show IB topology all links. So
In
again,
this,
can you help? Can you explain the difference again between just topology and all links?
okay, we know that there are some routes that go around and come back to us
Mm-hmm.
and then go back, and this keeps going. It keeps happening, so it's going to create a loop,
Mm-hmm.
right? So as I mentioned before, there is this whole concept of a backup route with EIGRP.
Yep.
When you have multiple routes to a destination, there is a possibility that one of the routes could be a loopy route. It will it'll go around and come back to us, and then
Yep.
it'll keep going around. You'll never reach the end destination.
Mm-hmm.
That route will not be shown in the show IP EIGRP topology
Mm-hmm.
table. It will not.
Yep.
To see every possible route to a destination along with the loopy route, you
Yep.
have to do all links.
Mm-hmm. Okay. Got it.
Your
Yeah.
topology, there's just two interfaces. I mean, you just have two routers. You're not going
Yep.
to see the difference there.
Yep. Yep.
Well,
Yep. Okay. Good. I got that. Okay. So now for this one, so we mentioned also, we said some values must match, before routers form relationships. We said the subnet mask, and the network must match. And then we said the autonomous system number must match. So if I want to see all the autonomous numbers that are used on this particular router, how do I see that? All the autonomous system numbers are used for AIGRP. Because if I'm troubleshooting, that's what some of the things that I'll be using.
yeah, that's very important for the exam, for this as well as OSPF. Just one command, show IP protocols.
Show IP protocols. Let's see. And then what do I see here?
Can you see on routing protocol is EIGRP1?
Yep, good one. So that tells me the autonomous system number. Yep. And
Okay, now
then,
you can ignore the rest. Those are the K values.
yep. And then if the K values differ from those ones, they're not going to form a neighbor relationship.
No,
Yeah.
they will not form any consistency, no neighbor. So you have to, reconfigure it back to normal.
Yeah. If I want to change the K values, how do I change the K values?
The K values, I think you have to go to the routing process. Can you go to
Router.
router EIGRP, with the metric 1.
Mhm.
Okay, and then you need to give metric.
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 Okay.
I think the first thing is TOS, which remains the same. I don't remember well enough.
Wait. Let's
Metric.
wait.
Yeah. Can you do a question mark?
Yeah.
Okay.
Let's
0.
wait. Yeah.
It
Zero?
remains as 0. Yeah, the first is a TOS, I believe. I don't remember very well, but yeah, and
You're correct, Sarah. The first one is TOS. That
Yeah.
should be 0. Then,
Mm-hmm.
yeah, K
then
series values.
yeah, this
So this is 10100.
yes. If you change, if you I think yeah, if you change them, you will start seeing these messages pop up.
Yeah. So
Yeah.
so yeah, I want to change them, for example, so we
Oh,
can see the
oh,
kind
no.
of message that we get.
I think the default K is I forgot again. K is one's 01001 or something like that.
It's 1
Okay,
0
make it
1
zero.
0.
Make it 202. Make it 2 now. 02
02
and 0100.
0100.
No, you need to give a space.
Okay. 020100.
No, no, you need to give a space among, yeah, all of them. Right?
Yeah.
And press enter now. Um,
Okay,
020100.
Under weight.
he wants me to type, okay, wait.
Yes, it's under
Uh,
weight.
yeah,
Okay.
metric weight.
So then I type 02
Two, 0100. Yeah,
0100.
00.
And then basically, because the K
Then
values,
see,
are not the same, then we
see the
got
adjacency has
this
come
one.
down. Metric
Yep.
change. K value mismatch. Yeah.
So that's one thing to watch out for in the exam. Like if all of a sudden, they're like troubleshoot like this thing within EIGRP, make sure that the subnet masks are the same. Check that. Check the show IP protocols that Seva mentioned. Check that the autonomous system numbers are the same. Check that the K values are the same. Check that the authentication are the same. So that's another thing that we should
Even your
comment on.
even your hello timers and date timers, you can change them.
Yes. Very important for the exam for CCNA, EIGRP, and OSPF. They will test you. Mark my
Yes.
words on hello timer, dead timer, especially with OSPF. They
Yeah.
will with EIGRP. They will test you on the ASN number.
Yeah, but with
So
EIGRP, the old time doesn't have to match.
with no, it
Yeah,
doesn't have to.
it doesn't have to match. Yeah. Okay.
So your
So
best
Okay.
friend during the exam is show IP protocols and show running configuration.
okay, so let's say I want to configure authentication for this particular EIGRP, you know,
Oh, I haven't covered
process.
authentication.
So if I want to configure authentication, how do I do that? Assad, Petros, anyone want to guide me through that? So I want to configure authentication. So basically, we've got a neighbor relationship going on between these two routers, but now we want to configure
Yeah.
authentication. So they have to, yeah, carry on.
Yeah, it would be MD5 is the authentication EIGRP support. So you have to type IP authentication, IP EIGRP authentication.
So I have to go out first of all
Yeah,
and type IP EIGRP, right?
yeah.
Okay. So let's go IP. I can't see EIGRP here. There's no EIGRP here. So how do I do that? How do I set authentication?
I think
So Powell says I do it on the interface. Okay. So let's go interface fast Ethernet 00, and then let's do IP EIGRP.
Authentication.
No.
authentication.
So what do I need to do? Power, yeah, I'm getting lots of answers. The Power says interface. Jerry says chain key. So what do I need to do first? If I want to, okay, Power says chain key first. Okay. So I exit from here again. So how do I do chain key?
Oh, I
Yeah.
haven't covered. I think you shouldn't be getting into
Keychain.
authentication now.
It will
No,
be
we have
good.
to.
Again, it's like part of like what we said. It's true that we probably shouldn't be getting into it now. But since we're already on the interface and so, it'll be useful knowledge, right? It won't be lost knowledge anyway. It would just be
Yes.
good to just, even if it's just, seeing it, just doing it. Give it a name. Okay, keychain. Okay, so let's go keychain. Let's call it EIGRP. Yep. So what do I do after that?
Key. Give a
Key,
key number.
Key number. Okay, let's say key number 1. So what else do I do after that?
Key string.
Key string, key again.
Key
So what do I
hyphen
do?
string.
Oh, okay, key hyphen string.
Then that would be the password. So you can
Okay,
type in it.
then password.
I mean,
Is it?
password would be the password
Yeah, okay. Then I go, is that it? I
to
just
the
go enter.
interface.
So first of all,
Enter.
I do the keychain, the key number, and then the key string. Okay.
Yep.
So now I have a key. So what else I can
Asad,
do?
Asad, just
Yeah.
to check, key string, is it visible? Is the one that is visible? Is the one that is encrypted or unencrypted?
Does
Can you
anyone
see
want to
it?
answer that question?
When I say show
Sorry,
run,
your voice was breaking. I couldn't get you. Can you come again?
Yeah. So the question is saying is that this key string that I just entered. So we define the keychain, right? And then we'll
Yeah.
set the key number, and then we'll set the string for the key string. So what you're saying is that this password is here encrypted by default in Cisco iOS or what?
it's not because
I
we
think
didn't
it
do
is
the
not.
yeah, we didn't do the MD5 hashing.
Ah, okay. So
Yeah.
Power said except we use the number 7, and then we can do that. Okay. Okay, yeah. So let's go
Yeah,
ahead. So
there's it. Yeah,
we've got our key
it
now. So
is it.
what do we need to
Yes.
do with the key?
You have to apply the key inside the interface where you have to apply, the authentication.
Okay. So I go
So you have to
exit
go into the interface.
interface first 00, and then how do I apply the key?
Should be
I think it's
EIGRP
IP
authentication.
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 I no, it's IPEGRP authentication.
There's no IP EIGRP.
Okay. Uh,
So I'm on the interface. So how do I apply the keychain that we've got now? So Jerry, how do I apply this keychain? I go IP.
service password encryption.
Ah, okay, yeah. So that will encrypt it. Okay, IP authentication keychain. Okay. So let's go IP authentication. Okay. Keychain.
One. Oh,
EIGRP. And then the autonomous system number, right?
yes.
The name of the keychain, which is EIGRP also. And then that's it, right? Yeah. And basically it's dropped that until I apply that at the other hand, then it's gonna start working also. So basically let's try to do this one really quickly. So if we go keychain or keychain EIGRP key 1 key string p. Then we go interface first, and it's 00, and then IP authentication keychain EIGRP, and then the number, and then the name of the EIGRP. Yep, and then we've got our adjacency back. So that's really good. And so if we want to see on this router, if we've got EIGRP authentication, we show IP protocol show us that one, Sarah. Will it show us if we've got EIGRP running with authentication?
I guess it will, or probably show run. Because I haven't played with authentication as yet,
Yeah.
so running configuration, at least that will show you the commands.
Yeah. Asad, what I mean, if I want to see, let's say I'm noticing that my adjacency is not forming, and I want to see if EIGRP support, if EIGRP is configured to use authentication on this router.
Mhm.
quickly without using Shoran? Is there a way that you can do without using Shoran?
Show IP protocol should be showing you the authentication method, but here in this case I think we did not mention the authentication method. Like it should be either MD5, that is message digest,
Mhm.
or the other one should be the clear text. We have only mentioned IP authentication keychain and we have given the username. I
Mhm.
think we'll have to mention one more command, that is IP authentication mode EIGRP
Mhm.
space MD5.
Mhm.
This is what I suppose.
So there's no other way for me to see if AIGRP is enabled except I do Shoran.
I
Show
think
IP protocol
isn't
should be showing.
detail.
Show IP, yeah,
Uh,
because show IP, I'm doing show IP protocols, but I can't see it here.
Yeah.
isn't detailed. Sure. EIGRP detail.
Show IP AIGRP detail. Okay,
Yeah. Wouldn't it show you?
there's no detail.
Oh, there's no detail on this one.
Show
Okay.
IP
I think that would be,
Show
what are we looking for?
will it?
If you want to
Yeah,
see
Sarah, please.
if authentication is if AIGRP is configured to use authentication.
Did you check running configuration?
Yeah, we can check that. But apart from running configuration, is there anything else? Any other way?
Show IP interfaces.
Show IP AIGRP interfaces or interfaces
Show interface.
detail, is it?
I'm sorry, I haven't done this.
Yeah, I think there's detail. We can just try detail.
Yeah. Detail is not telling me if AIGRP authentication is configured. So basically, for now, if we want to find out if AI show IP show IP
Authentication
AIGRP interface, but I can't really see if it is um
mode is not set.
yeah, it says mode not set. So show IP AIGRP interface mode. Okay, maybe I need to specify the interface. Okay, fast Ethernet 00. Um, Fast Ethernet 00. Anything else? Nothing. So how do I find out? So basically, the only way is to do show run and then do show run and then check under the interface if you've got authentication configured, right? And then check under your interface and then see if the interface that EIGRP is working out from, if you've got IP authentication, keychain EIGRP there. Okay, so I mean, it's really been very, very good hangout today. I mean, we went beyond like what you normally cover, like in CCNA stuff. Sure, IP protocols does not work. Yeah, it doesn't. I mean, yeah, it does for a lot of stuff. So that's like a really, really useful command because I mean, you see a lot of things in. I mean, basically, you get like an issue where you have to troubleshoot EIGRP, USPF, sure IP protocols, like what Sarah said. It's a really, really good point, because it covers a lot of things. It shows you whether the autonomous numbers are the same on the routers. It shows you whether their K values are the same. Yeah, and yeah, and then you can check the configuration on the interfaces, and then you can go from there. So I mean, we've covered a good thing today. We've learned some new knowledge and we've been introduced to some new things. There are also questions for us to go research, especially with EIGRP version 6 and also with EIGRP authentication and stuff like that. But it's really, really good. And that's one of the um, things that we are getting like me doing like hangouts like this. So really, really nice hanging out with you guys this week. It's really, really and girls. Sorry, it's really been a wonderful experience. Thanks very much, Sarah. You always bring like a wealth of knowledge. You're like a walking CCNA textbook. Or walking CCMP textbook, I should say. So, yeah, and yeah, it's been a really, really wonderful hangout. And then next week we'll actually do what is on the topic to do this week, which is AIGRP version 6 and all the other stuff. So I just didn't get around to changing like all the timing because work has been crazy. But yeah, we'll do that. Yeah.
Okay.
Did
Thanks,
anyone
guys.
get anything today? Did you get anything from today's hangout at all? And Petros,
Um,
was it useful for you? Or...
Yeah, it was very useful
Yeah.
because some of the things were I was not sure about. So it was like the authentication, it was quite an experience because unfortunately we didn't do the MD5 hash one,
Yeah.
where we encrypt the password.
Maybe we can do it like include that in like the next hangout
Yeah,
when we're doing
yeah.
the part two of the IGRP.
Yes, I've seen the videos regarding this. It's just that when we're doing practically, yeah, they
Yeah,
were just
exactly.
blank.
As
Yeah,
that happens to anyone, where you see something on video and it's like, yeah, that's easy. Then all of a sudden you go to the
yeah.
command line and you're like, oh, this option looks familiar. Okay, this other option looks familiar too, and this other option looks familiar. So until you
Even
actually get to, yeah, exactly.
even Sarah was guessing on some of them.
No,
Yeah,
but man, I tell you, like it's really really nice. I mean, there's, I mean, it's really like a good benefit to be able to ask like a lot of wealth of experience of wonderful people and stuff like that. So thanks
yes,
very much.
yes.
So we'll meet again next week, same time. We won't run over and stuff like that. Have a wonderful week, guys.
Thank you. Thanks,
Yeah,
guys.
and we'll meet again next week.
Okay,
Thank
Thank
you.
you.
Thank you, David.
thanks
No
guys. It
problems.
was
Yeah.
nice.
Bye bye.
Bye bye.
Yeah.
Okay, bye.
Bye.